So we talked about solving systems of equations with two variables last time, and we did that two different ways. We used substitution, and we did substitution whether it was linear or not. And then we used elimination also for linear systems. So kind of that's the preferred method. So what we're going to do today is we're just going to real quick, since we've talked about solving systems, we're going to solve systems with three variables. You can have systems with any number of variables. The more complicated, this happens in modeling, the more complicated a system you're trying to model, the more variables there's going to be. So this is just kind of extending it by one. So we're going to use the elimination method. So if you could eliminate with two variables, this is not going to be a problem. My biggest caution to you is just be careful of your signs and stuff. That's really the only mistake students tend to make on this on the test, is just not being careful with their multiplication, things like that. So what our goal is, we're starting off with this system. Our goal is we're going to pick one of the variables, either X, Y, or Z. If you see anything that you like there, I'll leave that up to you in just a minute. And then we're going to pick two pairs. So what variable do you want to cancel out, X's or Y's or Z's? Okay, let's do Z's. It's arbitrary. It really doesn't matter. Now, there is a slight advantage on this one on the Z's because it makes one step a little easier, but it's not going to lead to any different answer. So if you were thinking X's and you just didn't get to say it quick enough, that matters not at all. So what we're going to do is this. We are going to cancel the Z's out of two pairs of equations. So I see one pair right away. I'm going to cancel the Z's out of the bottom two equations just by adding them together. They already have opposites. So let's go ahead and do that. So I'm just gonna add these two things together. So 2x plus x is 3x. Y plus y is 2y. The negative z plus z, that cancels. And the 2 plus 2 is 4. Anybody concerned about what I've done so far? Now you're going to pick another pair, a different pair, and it doesn't matter which two. And you're going to cancel the z's out of those. I'm just going to use the top and the middle, okay, because they're right next to each other. You could use the top and the bottom if you want. It absolutely does not make any difference. But what you need to tell me is, how am I going to cancel the z's? What do I have to do in order to do that? Yeah, I've got a negative z right here, and I've got a positive 6z. So I have to multiply this bottom one by negative 6. So I'm going to put some parentheses around it, and I'm going to put a 6 right there to remind myself that's what I'm doing. And I'm just in this white space right here that's on the left part of my page. I'm going to rewrite my two equations so that there's no question about what's going on. So the top equation I am not altering. So I have 3x plus 9y plus 6z is equal to 3. The middle equation now becomes 6 times 2 is 12x. 6 times y is 6y. 6 times negative z is negative 6z. And 6 times 2 is 12. Does anyone not see what I've done right there? My goal is just to use the elimination method. And so that's exactly what I'm doing. I'm getting rid of one variable in two pairs of equations. So now I'll add these together, and 3x and 12x is 15 of them. 9y and 6y is 15y's. The 6z and negative 6z cancel, which is the elimination step. That's what I wanted. And 3 plus 12 is 15. So notice what I've done, just to summarize. I've gotten rid of the same variable. That's important. I've gotten rid of the same variable in two pairs of equations. So now I have two equations. I've reduced the problem to two variables. And so at this point, the rest of the problem is just like what you did on your homework, hopefully. So I'm going to take this equation that I've got. I'm going to slide it up here right underneath this, this first equation. So I'm going to rewrite it. 15x plus 15y is equal to 15. And what would you like to cancel there? The x's or the y's? X? Yeah, sure. That would be slightly fewer steps, but I don't think it's a big problem either way. If I'm going to eliminate the x's in these two equations, what do I have to do to make that possible? Close. Negative 5 has to be opposite sign. So I'll multiply that top equation by negative 5. So I have negative 15x minus the 10y is equal to negative 20. The bottom equation is positive 15x. We haven't changed the bottom equation at all, so I'm just rewriting it. And now I'm just about done. Okay, we've done all the hard work and heavy lifting of this problem. So the x's cancel, the negative 15x, the positive 15x, goodbye. The negative 10y and 15y becomes 5y. The negative 20 and 15 is negative 5. And we see at long last, I got the y value is negative 1. All right, so we've done 85% of the work. We're 1/3 done with the problem. Now what remains is, since I've got the y value, I need to figure out what x and what z go with that. So what I'm just going to do is I'm going to climb back up the ladder, and I'm going to take this y is negative 1, and I'm going to put it into either one of these two equations. It does not matter which one. You're going to get the same value no matter what. And in fact, what I'm going to do, just to keep my work as neat as possible, I'm not naturally a neat person, I'm going to take this y is negative 1, and I'm going to put it into this equation right over here, where I've got the white space right below it. So I've got 15x, and 15 times negative 1 is equal to 15. That's 15x. 15 times negative 1 is negative 15. I'm going to add the 15 to both sides and get 15x equals 30. Then I'm going to divide both sides by 15, and I get x is equal to 2. So there's my x value that goes along with the y. So now we've done almost all the work. We're 95% done with the problem. I just need to now figure out what the z value. And again, pick your favorite of the equations that we started with. There is no benefit to any particular one. I'm just going to use the bottom one because there's no coefficients. That's my only thought process, because I'm mathematically lazy. So x plus y plus z is 2. So I'm going to put x is 2. I'm going to put y is negative 1. And then z is what I'm looking for. Just for your notes, I'm hoping this doesn't distract you or make a big mess. I'm just going to draw a little arrow that just to remind you when you're looking at this later that that's the equation that I used to figure this out. 2 plus negative 1 is 1. And when I subtract the 1 from both sides, I get that z is equal to 1. So I don't know if you've done anything with three-dimensional space yet. If you go to calculus, you definitely will. It's a lot of fun. You got an x coordinate, y coordinate, z coordinate. So it's how 3 dimensions are modeled. So all you need to know at this point is we write our answer as an ordered triple. It's always alphabetical order. It goes x, then y, then z. So I'm going to put the x first. The x was 2. The y value is negative 1. The z value is 1. And there's my solution set. Just that one ordered triple right there. So that's the essence of solving a system that has 3 variables. You start out, you try to cancel the same value from 2 pairs of equations, and then you reduce it to what we did last time. So when you're done writing that down, if you have any questions, of course, shout them out. Let's make sure that we have everything answered that we need to have answered. In exercise 1, that's going to be your first problem. What variable the first time around, just so that we're all doing the same thing, what variable do you want to cancel the first time around? Y's? Okay, so that it has been spoken. We are going to cancel the y's in our first step. If you want to do something different, that is fantastic. I will be canceling the y's. And in fact, just to be even more specific, if you want to do what I'm going to be doing, I'm going to cancel the y's of the bottom 2 equations. And then just because I'm lazy, I'm going to cancel the y's of the top and the bottom equation together. That way we're all doing the same thing. If you need me for anything, wave your hand. I'm happy to walk around to you, help you with any sort of issues that you're having with the problem. I'm going to get started on this with the busy work. If you got somewhere where you're hung up, that is a great chance to ask a question. So I asked, so this was your pick. Somebody shouted it out first. What variable are we canceling? Canceling y. That's arbitrary. So when you're doing these problems on homework, it doesn't matter. A good reason to pick the y's is you notice we've got a negative y here. We've got positive ones here. So it's going to make my canceling easier. Okay, so now I'm going to cancel the bottom two just by adding them together. So 2x and x makes 3x. The positive y, the negative y cancels, which is what we wanted. And then for free, we also got negative z plus z. Those cancel as well. So we get 3x is equal to 3. So this is nice. Okay, believe it or not, that made the problem just accidentally a whole lot easier. Okay, I'll tell you why in just a minute in case you didn't notice. Now I'm going to cancel the y's. I picked the top and the bottom. You could have done the top and the middle. That would have been fine too. You would just have to multiply one of them by -1 if that was what you wanted to do. Again, there's no wrong process here. It's just a matter of making sure to take care of all your signs and your multiplication. So x plus x is 2x. My y minus y, those cancel. The z plus z is 2z. And then the 2 and -2 is 0. So here's what happened accidentally. I now know what the x value is. What's my x value going to be? 1. That worked out great. So I forgot this problem was nice and relaxed. For your first one, the x value is 1. Now I'm going to take that x value and I'm going to go over here and say, oh, okay, now that I know the x value, this equation allows me to figure out the z value. Okay, so I'm going to take that x is 1. I'm going to plug it in. I'm going to plug it in right over here. So I'm just going to draw a little arrow for your notes. So later on, when you're looking at this and your short-term memory is burned out, you remember what we did. So x is 1. We've got 2 times 1 plus 2z is equal to 0. So 2 times 1 is 2 plus 2z equals 0. I'm going to subtract the 2 from both sides. Divide by 2, and we get the z is -1, so that's nice. The x is 1, the z is -1. And at this point now, I didn't tell you what exactly to do, so you're on your own at this point, but we will all have the same thing for the y value. Pick your favorite one of these 3 equations we started with. It makes no difference whatsoever. I'm going to use the middle one just to show you that that's probably not the one you picked. Then we should all end up with the same y value. So the middle equation is 2x plus y minus z equals 5. So that becomes 2 times x is 2 times 1 plus y minus z, which is minus -1. This is where you have to be careful of the signs. Okay, it's really the one thing students mess up on this. So just, I know you're in the middle of the test and it's a little stressful, but just take a deep breath and be careful with those signs so they end in the right place. So we have 2 plus y plus 1 equals 5. 2 plus 1 is 3. And when I subtract that 3 from both sides, I get that the y value is 2. There we go. My ordered triple, the x value is 1, the y value is 2, the z is -1. Now that one ended up a little easier than my original example just because 2 variables cancel. Sometimes it'll happen, but sometimes it won't. It's not going to happen in your next problem. Okay, another example. So I'll slide this back up here in case you're still copying, but I want to get everybody started on exercise 2. So again, this is a you choose. X's or Y's or Z's. How are we going to start this problem out? What are we going to cancel? X's. Okay, I heard X's first. So I'm going to cancel the X's along with you. I think right away you can see an obvious pair of equations to cancel the X's out of. That would be the top and the bottom. And just so that we're all doing the same thing, this is not what you have to do if you're on your own. I'm going to do the bottom 2 equations as my other pair. Okay, so if you want to be doing the same thing I'm doing, that's the other pair I'm going to use. Let me get started with the busy work. So again, if you're hung up somewhere and you don't understand why, that's a great opportunity to ask a question. So I asked you what variable we're going to cancel off to start with. I was told x's. That sounds great. Y's or z's would have worked equally as well. But with the x's, if I add the top and the bottom one, you notice I've got a positive x, a negative x. It's going to cancel out right away. So that's great. So I'm going to do it. So x plus negative x, no more x's. And then I have negative 3y and negative y. That's negative 4y. I'm going to write that right there. And then negative 2z plus 4z is plus 2z. And then negative 3 and 3 is 0. And so there we go. We eliminated the x's first. And there's my first equation. So far, so good. Anybody get something different? Again, this was arbitrary. I chose this for you just so we're all doing the same thing. You could have done the top and the middle equation. That would have been fine. But I'm going to do the middle and the bottom, and I'm going to eliminate the x's there. In order to do that, notice I have a 3x in front of this one and just a negative in front of that one. So that means I need to multiply this bottom equation by what? Yeah, I need to multiply that one by 3. So I will. So the middle equation stays the same. I've got 3x plus 2y minus z is 12. The bottom equation, I'm going to multiply that whole thing by 3. So 3 times negative x is negative 3x. 3 times negative y is negative 3y. 3 times 4z is plus 12z. And then 3 times 3 is 9. End result here, 3x minus 3x, those cancel. That's great news. The 2y minus 3y is negative 1y. The negative z and 12z is 11z. And then 12 and 9 is 21. Hopefully we're all at the same place. If we're not at the same place, hopefully you understand why. Maybe you made an arithmetic mistake. The rest of this is just what we did in the last section. I'm now going to combine up these two equations and I'm going to solve them for one of the variables. So let me bring them. I'm going to smush them together right here. So I've got the negative y plus 11z is 21. And then the negative 4y plus 2z is 0. Again, this is an arbitrary question. Which one are we going to cancel? The x, or excuse me, the y's or the z's? Which one goes? Okay, I've heard a couple people say why. If you got rid of the z's, again, there's nothing wrong with that. We're going to end up in the same place. But I am a man of the people. I'm going to do exactly what I was told. So that means I have to do what to this top equation? I got to multiply by what? Negative 4. I think that's what I heard somebody say, but I'm distracted by the wind coming out of the air conditioner here. So multiply that top one by negative 4. The reason, in case you didn't see that, is I've already got a negative 4 in front of this bottom y. I need a positive 4 in front of the top one. Okay, so I'm going to multiply this by negative 4. I'm just going to write it right here just to save myself a little space. So negative 4 times negative y is plus 4y. Negative 4 times 11 is negative 44. And then negative 4 times 21 is negative 84. So 2 and negative 44 is negative 42z. 0 and negative 84 is negative 84. And when I divide both sides by negative 42, I get that my z value is 2. Oh, that's great. Happy day. And now I just go back through like I've done before. I'm going to go ahead and take this z as 2. You could use either of these two equations that involve the y and the z. I'm going to use this one right here. And so the z is 2 is going to be negative 4y plus 2 times 2 equals 0. Negative 4y plus 4 equals 0. I'm going to subtract the 4 from both sides. I'm going to divide both sides by negative 4 and get y as 1. And then last but not least, it's the same process every time. So once you get used to it, you're doing the same thing every time. So I'm going to take this y as 1. I'm going to take this z as 2. I'm going to find my favorite equation here up of the original 3 and use it. I'm just going to use the top equation. So the top equation is x minus 3y minus 2z is negative 3. I just picked that arbitrarily. I have no secret mysterious reason for picking that at all. and I'm going to plug in my values. I've got x minus 3 times 1, which is the value of y, minus 2 times 2, which is the value of z. Negative 3 times 1 is negative 3. Negative 2 times 2 is negative 4. And then I have x minus 7 is negative 3. And when I add the 7, my last part of my ordered triple is 4. So let me write my answer. The x value is 4, the y value is 1, the z value is 2. And you can see that these systems of 3 equations with 3 variables, it's mostly just busy work. Okay, so sorry about that. I'm not usually into just doing busy work, but it's unavoidable today. I got one more example for you. So you're running out of time to ask questions about solving systems of 3 equations and 3 variables. This last one, again, I've given you one that's kind of a little bit of a special case that's a little easier. It saves you one step out of all the steps. I just want you to notice for me this bottom equation. I'm just focusing on that. What's missing from the bottom equation? Okay, there's no y there. So when that happens, you should take advantage of that. What you have is you already have an equation that's missing the y. So what I would do if I were you is then from these 2 equations that are right above it, I would use those 2 equations and cancel the y's out. That way you can use whatever the result here of the top 2 equations is, and you can use it with this, and you can then be much closer solving the problem. So I'm just going to write right here for your notes that I would recommend eliminating the y value, and then you'll have 2 equations with just an x and a z, and then you can proceed from there. So I'm going to give you a couple minutes to make some progress. If you need anything from me, if this is not syncing up with your brain, wave your hand, let me come to you and then help you with your steps, please. I'm happy to help you. I'm going to get started with the busy work. Check your work with mine. If you got any questions, this is my last example of this. I'm hoping it's fairly straightforward for you. Again, I want you to do great on this last test. I'm going to put a couple of these on there. Hopefully that's a good thing. So again, taking advantage of this bottom equation already has no y's. I'm going to eliminate the y's on the top one or top two. So I've got a 2y and a 3y. So what that means is you're either going to multiply this top one by 3 and the middle one by -2, or you multiply the top one by -3 and the middle one by +2. Okay, either way, that's going to work. So when I multiply the top one by 3, I've got 9x plus 6y minus 3z is -3. The middle equation becomes -6y minus 2z is -24. And if I've written things down right, and if I've done my arithmetic right, here's what I get when I add. I got 9x. The y's cancel. Goodbye. -3, -2 is -5z is equal to -27. So now, like I mentioned, I've got this equation that was already given to me, so it was free. That has no y. I've created this equation here with no y. Now I can go ahead. This problem is like we did in class last time. So I'm just going to take this equation now. I'm just going to bring it right down here. And so I've got x minus 3z is -3. Again, I left this open-ended. You could either cancel the x's or the z's. Absolutely does not matter. I'm guessing probably most of you canceled the x's because you only have to multiply one equation by something. So I'm going to do that. I'm going to get rid of the x's here by multiplying this equation by -9. So the top equation, 9x minus 5z is equal to -27. Nothing changes there. The bottom one becomes -9x. That's good. That'll cancel. And then I have plus 27z. Okay, that's an awkward number. And then -9 times -3 is positive 27. (9x minus 9x), those cancel. -5z plus 27z is 22 of them. -27 plus 27 is 0. That's okay. 0 is a number. Don't be scared of it. And when I divide both sides by 22, when I have 0 of something and I divide it into 22 parts, I've still got 0. And then the rest of this is just resubstitution. Okay, so again, same steps every time. Once you get used to it, there's no mystery. There's nothing tricky or gimmicky about these problems. It's always the same steps. So I'm going to take this z. I'm going to plug it into this bottom equation right here. So I've got x minus 3 times 0 is equal to -3. Well, -3 times 0 is 0. So that just tells me x is -3. Oh, I like that. That works out good. 0 is always a fun number to substitute. And then I've got my z, I've got my x, pick an equation. It doesn't matter. In fact, I'm going to take advantage of this middle one just because I'm feeling super lazy today because this one has no x. So I've got 3 times y plus z, which is 0, is equal to 12. And when I divide both sides by 3, I get y as 4. Okay, so that worked out in a lovely fashion for me. My x is -3, my y is 4, my z is 0. Woohoo! There it is. Again, mostly busy work. Sorry about that. I usually like things to be a little more exciting than that, but I had to show you that because this is important for your final exam. Okay, so what we're going to do with the last few minutes of this section is these word problems. What we're going to do, just because, okay, so example 2, this is my example. So we're going to go through, we're going to set up the system, and we're going to leave it right there. So this problem says a total, let me stop, because it's always good to look for keywords when you're solving word problems. What does the word total mean? Yeah, we added up the sum. Perfect. A total of $2,000 is going to be invested at 1%, 2%, 2.5%. So the percentages are small just to keep this problem nice and relaxed. Okay, not because those are good investment options. And then I tell you some relationships about the amount you're investing. The amount invested at 2.5% is 6 times the amount at 1. The total interest for 1 year is $44. So yeah, big deal. Use the system of equations to determine the amount invested at each rate. Great. Okay, we can do this. So I have 3 accounts. That's why we're doing this here. 3 equations, 3 variables. That is our goal. So I'm going to define the variables straight away. I'm going to let X be the amount that I invest at 1%. I'm going to let Y be the amount I invest at, what is it, 2%. And then I'm going to let Z be the 2.5% amount. Okay. And now what I'm going to do is I'm going to use equations from each of the 3 sentences I've had, and you're going to help me. So the first one, we already identified what the word total means. A total of $2,000 is to be invested. I've defined these variables to be the amount we're investing in each of those accounts. So what's an equation that I could write for that first sentence? A total of $2,000 is invested. Bam, yes. X plus Y plus Z, that's total. I'm adding up the amount for each account, and that adds up to 2,000. Good, there we go. On the test you take a week from now, I'm going to have you do this once or twice. I'll give you a point for each of the equations. Okay, so even if you can't do the whole thing, which I hope you can, but even if you can't, do what you can. Okay, partial credit is better than no credit. Okay, the second sentence says, the amount invested at 2.5% is, now I'm just going to remind you, some math teacher at some point in your life has probably told you this before. The word is means equals. Okay, so the word is dividing up your sentence. So the amount invested at 2.5 is 6 times the amount invested at 1%. So let's write this symbolically. The amount invested at 2.5%, what is that? That's Z. Is equals 6 times the amount invested at 1%. What's the expression for the right side of this equation? What was that? What'd you say? Somebody over here said it. 6x. 6 times the amount invested at 1%. That's why I defined those variables, to make the translation part a little easier. I know this is not an easy thing, so I said a little easier. It's a comparison word. Well, what I'm going to do before I go and finish this is I'm going to bring the 6x over, because if I'm going to solve a system, all the variables have to be on the same side. So I'm going to bring the 6x over here by subtracting it. And that makes the equation negative 6x plus z is equal to 0. That's my second equation. And I think the third equation is probably the hardest one. Again, we have the word total, this time the total interest. Does anyone remember how to calculate simple interest? What do I do? That's a good thing I asked. How do I work with percents? If I'm earning, let's just pick the 2%. If I'm earning 2% interest on my deposit, what am I going to do with the number 2% and the amount that I put in the account? Yes, multiply. What numbers am I going to multiply? 0.02 and then whatever the amount is. Yes. So each of the interests is just going to be that percent times the amount. So here goes. The amount of interest I'm going to earn on the 1% is going to be 0.01 times how much did I invest at the 1% account? There you go, X. Yes, that's why I define the variables. I don't know. That's what I'm trying to figure out, the exact value. Plus, what's the expression now that I've done the first one? Now, hopefully that helps you. What's the expression for the interest for the 2% account? Yes, 0.02y. Okay, third time's a charm, everybody. What's the expression for the interest for the 2.5% account? 0.025z. Great. We always move that decimal 2 places to the left. And then we're told in that sentence that the total interest is $44. So that equation is going to equal 44. Now I'm done with the problem. That's all we're going to do. I am going to give you one hint, though. If you do want to solve this, it's always easier to work with whole numbers. And we mentioned this, we did mixture problems way back at the beginning of class. I'm sure it'll be a review problem that you want to see on our final exam review. If I want to turn all of these coefficients into whole numbers, I've got 0.01, I've got 0.02, I've got 0.025. What should I multiply all these numbers by to get rid of the decimal? Okay, 100 is a choice, and it wouldn't be too bad because 100 times 0.01 is going to be 1. 100 times 0.02 is going to be 2. But here's the problem. 100 times 0.025 is going to be 2.5. So I should multiply by 1,000. So we're going to multiply here everything by 1,000 to get rid of all those decimal places. And so what that changes, that bottom equation. So if you're solving this, this is not a required step on the test because I'm not going to have you solve the word problem. I'm just interested in you setting it up. But when you're doing your homework, if you want to practice, I would recommend getting rid of the decimal. So 1,000 times 0.01 is 10x. 1,000 times 0.02 is 20y. Then 1,000 times 0.025 is 25z. And 1,000 times 44 is 44,000. And there's the system that you would solve. Okay, I know this is difficult stuff. I get it. We hate word problems. Our stomach clenches and we don't like to do this. That's why I'm just having us set this up. So I'm going to give you a couple minutes. Exercise 4. I've given you all the information you need in that. My one tip for you going into the problem is define your variables straight up. If you need me, wave your hand. Let's talk. I'm happy to help. Okay, so first thing I'm going to do here is I'm going to define my variables. And it doesn't matter what letters you use. It doesn't matter what order you put them in. That's fine. So your letters might look different. That does not affect the rightness or wrongness of your work. So I'm letting X be senior tickets, Y be adult tickets, Z be student tickets. So the problem says 3 students are buying different combinations of tickets for a baseball game. So let's go one student at a time. The first student buys 2 senior tickets, 1 adult ticket, 2 student tickets, and pays $25. So someone give me an equation that represents that. Okay, so whatever letter you used for senior or Adult or student. So 2 times whatever letter for senior, I used X. 1 adult. So I'm going to write the 1 times whatever letter used for adult, which I used Y. And then 2 times students, so I used Z for students, and that is equal to 25. Okay, there's my first equation. Okay, the second student. Okay, so again, if you did not get that first equation, be thinking of what you might write down for this second one now that you see. The second student buys 1 adult and 5 student tickets for 24. So somebody else give me an equation for what the second student buys. Great. 1 times whatever variable you used for student, 1 times whatever variable you use for adults, plus 5 times whatever variable you use for students is equal to 24. Fantastic. So again, be thinking ahead. Here's the last equation. The third student buys 2 senior, 2 adult, 7 students for 49. Okay, so somebody else give me that equation. Yes, 2 times my seniors plus 2 times my adults plus 7 times my students is equal to 49. And there you go. There's the system of equations that you would solve in order to get the prices of the tickets. I've got one more problem. There's several of these in the homework to please practice. Okay, I want you to get the points on my test. I want you to get the points if this occurs again on the final exam. Okay, so the last one is exercise 5. I've given you again all the information. Just as a little hint, I think better when I can with a picture. So I personally would draw a picture of this one involves a triangle and have a, it doesn't matter, a large, a small, and a medium. I know that the picture does not reflect that. That's why I labeled that. And then use your letters. I would define each of those to be an X, Y, Z, or A, B, C, or whatever letters you like, and then use that to figure out the equations you need for the problem. So it does not matter which angle you let be X, Y, or Z. I'm going to use those letters. I'm just going to make X the small one, Y the medium one, Z the large one. I have no reason for doing that. So if you have yours in a different order, that's fine. Okay, that's not going to affect anything. So just know the correlation. So the first equation hopefully wasn't too bad for you to get. I think the first equation is the easiest one. It says the sum of the measures of the angles of a triangle is 180 degrees. So what's that first equation going to be? X, the first angle, plus Y, plus Z is equal to 180. Okay, that is just straight. The sum of the angles is 180. All right, so the next ones we have to be careful translating. So the next sentence says, in a certain triangle, the largest, so I'm going to pause for a second and underline the word largest. Whatever letter you used for the largest. Okay, I used Z, so I'm going to start off with that. I'm just going to put that right here, Z. So if you used A or X or whatever letter you used for the largest should be right there. The largest angle measures, so the largest angle is going to be equal to 55 degrees less than twice the medium. 55 degrees less than twice the medium. What's the expression for 55 degrees less than twice something? Perfect, good order. So what I heard was 2y minus 55. Now I know some of you are thinking, hey, the 55 came first in the sentence. 55 degrees less. Shouldn't it be 55 minus 2y? And the answer is no. Okay, unfortunately, the words less than means you're taking whatever you start with, and that's being deducted by whatever comes after. Okay, so if you have $5 less than yesterday, that means whatever yesterday's total was, you subtract 5 from. That's just how those words work. So I'm going to take this 2y, I'm going to bring it over to this side right here, because the x's and y's are always on the same side of the equation. So I'm going to have negative 2y plus z is equal to negative 55. At this point, I'm going to pause for a second. Remember, if you defined your variables in a different order than me, you could have things over here in a different order. That's fine. Okay, don't freak out. I will figure it out on the test. I can look and see what you did. That's my happiness to do that. Okay, the last one, it says the smallest. So again, I'm going to stop. Whatever letter you used for smallest, you should start with. I used X for smallest, so I'm going to start. The smallest measures, so the smallest is equal to 25 less than the medium. So what's 25 less than the medium according to my letters right here? Thank you. Y minus 25. And so again, I'm going to take that y, I'm going to bring it over to the other side by subtracting it and have x minus y is equal to negative 25. And there's my system of equations that I would use to figure out the measures of the angles of that triangle. Difficult stuff. I know that. Word problems and translating into equations into a different language is a very tough thing.